Measuring angles and arcs. So we got something called a central angle. This is going to get very confusing as the chapter progresses because we're going to look at a whole bunch of different angles. And the question that you have to ask yourself every single time is, where is the vertex of the angle? That will help you solve all kinds of problems. So we're going to start with the most basic, which is called a central angle. Clicker. There you go. There's a central angle. Oh, by the way, what's that thing?
Theta.
I'm sorry?
Theta.
Theta. Well said. I know you're all practicing your Greek letters at home. There's a central angle. So what is a central angle? Emmett?
A angle with the center of the circle as its vertex.
Works for me. Trying to think of a counterexample that would nullify that, but that's pretty solid. A circle whose vertex is at the center of the circle.
Wait, a circle?
Did I say it wrong?
Yeah.
Yeah, it's me.
And it's a segment whose circle is near the center of the earth with the Greek letter beta in a playground with a big slide. It's an angle whose let me try this again. An angle whose vertex is at the center of the circle. Is that right, Megan? Okay, good. And since we're working on our Greek letters, I chose to make that angle theta. Hey, well done. How big is that angle? You are just digging yourself a grave. Approximately how big is that angle?
70.
80, 70. What isn't that angle?
112.
112, good. Okay, now we got an arc. That's not a picture of an arc. I'll show you an arc in a second, but what's an arc? Spelled with a C, not a K. It's not a boat. Well, that would get at least a chunk onto somebody. What's an arc? No idea? Okay, how about that? What's an arc? That's an arc, by the way. What is it? Say what? The outside of a circle. The part of an part, huh?
Part of the circumference.
Stop, go back to what you said originally.
Part of the circle.
Done, stop. Okay, it's a chunk of a circle. We don't talk about inside and outside of circles. Okay, circles don't have insides. Circles are just the line, they're not lines, but that thing that makes up the circle. When we talk about the stuff in the inside of the circle, that has a different name called a circle interior. So inside and outside of circles we'll talk about later. Remember, our circle by definition is that hula hoop. And if we take a piece of it, we get an arc. Okay, good. Now some notation. We want to be able to talk about arcs. There are three types of arcs we're going to talk about. A minor arc, a major arc, and a semicircle. Minor arcs are arcs that are under 18 years old. Oh, it's a rough crowd today. It doesn't get much better than this, kids. Minor arcs are arcs that are less than 180 degrees. Major arcs are arcs that are greater than 180 degrees. And semicircles are equal to 180 degrees. This is the, yes ma'am?
What's the AB and AC?
I'm going to get there. Okay. This is the first time we start talking about things that have angle measures greater than 180 degrees. So we will have arcs that have a measure of 210 degrees. The major arcs go from 180 up to 360. So Megan asked a good question. What is this stuff over here? This is the notation for denoting an arc. If you want to talk about a minor arc, you list the starting point and the ending point and you put a little arc symbol over it. If you're doing a major arc, you need 3 letters. And if you're doing a semicircle, you also use 3 letters, and we'll talk about that in a second once I get a visual for you. Okay, so minor arc less than 180, major arc greater than 180, semicircle equal to 180. Okay, we good? about now?
No.
No?
It's still okay.
Go ahead. I got no place to go. Oh, wait, let's go back, hold on. Let's go back to this guy. Okay, and talk about each of these circles. We'll do a little bit more with this in a slide or two, but just to get you started, let's call that A, let's call that B, let's put a C over here. Okay. The minor arc means go from A to B as quickly as possible along the shortest path. That would be the minor arc AB. Hi, Mose.
How are you?
Good. How are we looking for lunch today?
Good.
Awesome.
You're going to Moe's?
No, that's Mose.
Oh.
She's going with us to lunch. Major arc. Go from A to B, but pass through C. That's why you need 3 letters for major arcs. Okay, go from A to B, but pass through C. And then a semicircle, let's call that D. You have to use 3 letters also, because if we're talking about a semicircle, you have to make it the difference, or denote the difference between that semicircle or that semicircle. So again, 3 letters. We'd have a semicircle ABD and the semicircle ACD. And those are different semicircles. Say measure, different semicircles. Okay, make sense? Good. Okay, AM, arc measure. We'll talk about 2 different things, arc measure and arc length. Arc measure is always given in degrees. Arc length we'll get to in a little bit. So, the measure of the central angle and the measure of the arc are identical. So if you'll remember back on that previous slide, I asked you approximately how big did theta look, and someone said, let's say 70 degrees. If theta is 70, then the measure of the arc is also 70 degrees. A semicircle has a measure of 180 degrees. That's because that central angle there is 180 degrees, or a straight line. Okay, so there it is summarized. This theta here is the same as the arc measure of that thing. So we don't really have a way to measure the arc measure other than using the corresponding central angle. And again, notice the notation down here. The measure of the arc AB, because it's got the arc symbol over, is equal to the measure of angle AMB, which is that central angle, also known as theta. Make sense so far? Beautiful. Arc length is a different story. Arc length we can measure using traditional measuring techniques like a ruler. The question is, how would you find the arc length? So if I go back to this picture and I ask you to find the length of AB, the length of the arc AB, how would you do that?
First line the circle, first of the circle.
Good. That's a good start.
Then can you just find the circle and wait? After that.
Okay. Good start. Anybody else? Michael?
Do you have to find the circumference of the circle?
Yes, that's what he just said.
Sorry.
No, don't be sorry. That's okay.
Wait, what about
You're
the
reaffirming that helped his self-esteem. We coming back to you?
Yeah, what about radius and the diameter? You could find that and use that to find AB, can you?
I don't know. How? Molly, was that you with your hand up, or Morgan, did you have your hand up? No? Cole?
Would you multiply the central? Does it have something to do with the central angle?
I don't know. I mean, I do know, I'm just not gonna tell you. Paul?
Could you put the central angle over 360 and then the arc measure over the circumference?
I feel that might be right, because Shep has just pointed at you.
I wanted it because that's what I was thinking.
He stole your idea? That's not cool.
You didn't
Why would I
ask.
put theta over 360?
Because that's the full angle measure of the circle,
What is?
360.
Okay. But you didn't answer my question. You just told me what the 360 is. Why would I put theta over 360?
Oh, because theta over 360 is equal to AB over circumference.
Does that make sense?
Yep,
Yeah.
What did he just do?
make a proportion.
He set up a proportion. Okay. So that, let's think of it in simplistic terms. If I want to find the length of a semicircle, what percentage of the circle is the semicircle? Not a trick question.
1/2.
It's 1/2 or 50%, correct. If I want to find the quarter of the circle, it's 1/4 of the circumference. So by setting theta over 360, we generate the ratio of the arc to the entire circle, which is the circumference. So we get that. AL is arc length. Arc measure is the same thing as theta, so it's our central angle. Put that over 360. That's the fractional part of the circle we're talking about. Is it half a circle? Is it a quarter circle? Is it 7/13 of a circle? And then multiply that by the circumference. You will get arc measure and arc length confused. Remember, arc measure is measured in degrees. It's the same as the central angle. Arc length is an actual distance. How far will I travel if I walk from A to B along that circle? How are we doing so far? Okay. This is fairly simple. Adjacent arcs are just two arcs that are next to each other, share a common endpoint. So the purple one ends, the red one starts, that makes them adjacent, they share a common endpoint. We don't use that a lot, but it does pop up occasionally. So you at least, I just wanted to at least expose you to the term. Okay, not real exciting. Let's move on to some more fun stuff. Here we go. All right, Mary, name a minor arc in that picture.
RSO.
Say again? I didn't hear you.
RSO.
RSO. No, that's incorrect.
Okay.
Try again.
FSR.
FSR. No, we're looking for an arc, not an angle.
Oh, okay.
Just a second.
Sorry.
I understand.
RO.
RO. Perfect.
Okay,
Give me
now I
another
get
one,
it.
Mary.
FR.
Good. Got another one?
GF.
G.
Oh.
No, I just didn't hear what you said. That's all.
Oh, GF.
Go for ferret.
Sure.
Okay, what's the other one?
GO.
Geo. Go for octopus. Well done. How about a major arc, Emily?
G past R to F.
Once more.
G past O to R. Wait, no, not that one.
No.
R past O to F.
Correct. And you could just list that as ROF with an arc symbol over it. Okay? Give me another one.
O F G.
Good. Notice if I go from G to O, when Mary was driving the bus, she took the shortest route, so that was GO, which is the minor arc. With Emily, she went G to O, but she needed to pass through the other points. You only have to list one other point there, so you could call that arc GFO or GRO. It's the same thing. It's that major arc. Okay. Ben, how about some semicircles up there?
GOOR. Oh, semicircles?
Yes, sir.
GR.
Which one?
What do you mean? Oh. What?
Which one?
GR.
Which
GSR.
G. I didn't hear the second.
Oh, GOR.
GOR or
GFR.
GFR. Again, you gotta make a distinction in a semicircle with 3 letters. And then, how about 2 adjacent arcs? Well, pick an arc. Which one do you like?
RO.
RO. What arc is adjacent to RO?
FR.
Perfect. They share a common endpoint of R, so we're good to go. Okay, problems there? Okay. The notation is what's going to trick you up. Remember, minor arcs, you need only 2 letters, but when you talk about major arcs or semicircles, you got to have 3. Okay. Going from the first point to the second point, passing through the other point. All right, now we start cranking out some numbers. If RSO is 57 degrees and FS is 8, find the measurement of GO and the length of RO. So the measurement of GO should be in degrees. The length of RO should be in whatever our units are. Let's call them centimeters. Let's start with the easier one. How big is GO? Arc GO, I should say. Hmm?
123 degrees.
Why?
Because GR, like, was semicircle and GOR.
Mhm.
Semicircle, so that entire thing is 180 degrees.
Mhm.
Then you subtract 57 from that and you get
Two ways to approach it. How big is this angle?
180 minus 57.
Yeah, 180 minus 57, which is 123, because they're a linear pair. That's the center of the circle. Therefore, the arcs match the central angles. That would be 57. Therefore, that would be 123. That's one way to do it. The second way to do it is forget about this stuff and go from here. If this is a central angle, that arc is 57. This whole thing would be a semicircle, which has a measure of 180 degrees, and therefore 180 minus 57 gives you 123. Same thing, different approach, same answers. All right, how about the length of RO? How do you find that? Megan?
You do 57 over 360 times 50.3.
Times what?
50.3.
50.3. Okay, so what I don't know is where that 50.3 came from. So I'm going to start with this. AM over 360 equals the circumference, which is 2 pi r. Start with the blank formula, plug in what you know. We know the arc measure is 57, and we know the radius is 8. Then take that and get to that. What do you got for a final answer, Megan?
7.96.
Can somebody confirm that?
Yes.
Beautiful. 7.96 centimeters. Okay, good. Again, start with a blank formula, plug in what you know, solve for what you're asked to solve for. Any problems there? Okay. Find the length of DA. Again, it's a length, so this one should be in terms of, what are we doing, centimeters? That 12, by the way, is the diameter. In a picture like this, if the number that you're talking about is it towards the center of the circle, it's going to be the diameter. If it was a radius, it would be moved to the left or to the right. Stand up, sit down, 5, 5, 5.
Wait, that 28 like B or B or C?
28 is angle DBC. donkey, badger, cat.
Like 12 AC.
12 is AC, correct. Aardvark, cooler. Alright, little bit of confusion, not everybody has the same answer. Seems to be the common answer would be 15.92.
Yeah.
Okay. What's AM?
152.
152, where'd that come from? I mean,
180 minus 28.
good, so we want the measure of this arc, or sorry, we want the measure of that angle, or we want the measure of this arc. It's the same thing. What's the radius? 6. So 152 over 360 times 2 times pi times 6. Or if you want to slap the diameter in there because you're given the diameter, you could do that too. Plug and chug and solve. And be careful how you solve that. I don't think you need parentheses there, but just to be sure, slap the 152 over 360 and you get, what did I say, 15.92?
Yeah.
15.92
Centimeters.
centimeters. Okay. Those of you that did it wrong, do you know what you did wrong? Yeah? What, Molly?
I took the angle of 28 and I put it in.
Use the wrong angle. Okay. Anybody else? We're solid? Okay, good. Blank formula, don't forget. No. There we go. Oh, wait. Have we done this one yet?
No.
This will be good. Who wants to try it?
Who?
All right, Madeline. You ready?
What do I do?
You have to read the word, not the color,
Okay.
I think. Wait, look, cover your eyes. Don't look. Don't cheat. There you go. All right, don't cheat. Oh no, you gotta say the color, not the word.
So I will say.
And you gotta do it as quick as possible.
So it will say the word, and I have to say the color
You say the color, doesn't matter what it says, you say the color.
of the word.
You gotta go across and, read it normally. As fast as possible. Ready? Wow, that wasn't very fast. Let's try it. Maybe you missed that part.
Yeah.
As fast as possible, okay? We only got 50 minutes. You ready?
Green, red, blue, yellow, blue, green, black,
Ah.
red, blue, green, black, red, yellow, green, blue, black, blue, red, or green.
Or green.
That's so hard.
Anybody else want to try?
I might do it.
Wow.
Emmett,
Okay.
ready?
Green, red, blue, yellow, blue, black, red, blue, green, black, red, yellow, green, blue, black, blue, red, green.
That was so good.
Well done.
Nice.
Beautiful. Day 2, I'll unlock it in a second. Quick scheduling change.